Example 9. A force of 18 pounds is required to hold a 74-pound crate on a ramp. What angle does the ramp make with the horizontal? Round to the nearest tenth. All right, so clearly this is an incline problem, so I need to begin by drawing this out. Okay, so here's the horizontal, and then we have this ramp. We don't know the angle of incline, okay, so that's what we're looking for. So I'm just going to call this theta. My goal is going to be to find theta, okay. So then we have this crate sitting on the ramp. I'm just going to designate the crate with a dot, okay, and it weighs 74 pounds, so that's the weight vector, okay. Weight is a force that acts straight downward, so you have to draw in this vector, okay, so it goes straight down, so this will be a right angle, this will be a right angle, and we know because this thing weighs 74 pounds, this vector has a magnitude of 74, okay. We also know that there is a force of 18 pounds required to keep this crate in place. So if you have the crate, okay, we don't want it to fall down the ramp. So there's some force that needs to act in this direction to hold the crate in place. Okay, so this force vector, I am going to draw it along the ramp. Okay, we'll go ahead and say like this. Okay, so this particular vector has a magnitude of 18. Okay, so based on all the information in the problem, this is how you need to do the drawing. Okay, now we can start working to figure out what theta measures. Okay, I am going to begin by focusing in on this yellow triangle. Okay, it is a right triangle. We know obviously that there's a 90-degree angle, and then one of the other angles is theta. Okay, we know the angles in the triangle have to add up to 180 degrees, but we can't say what the other two angles are, theta, and I'll call this angle alpha. We don't know what they are because we know that theta plus alpha has to equal, if we add these two angles, we have to get 90 degrees, okay, but we can't say at this point specifically what those measures are. Okay, so now that I've got this angle alpha labeled on here, okay, I am going to work with this. I'm going to move over to like where the 18 vector is, where that red vector is, okay, and I'm going to make a parallelogram. Okay, so I am going to draw straight down, okay, and I'm trying to make sure that this side is equal to this black side. Okay, I'm trying to make this equal to this. Okay, so this should also measure 74. That's its magnitude. Okay, and then I'm going to draw in a side parallel to the red vector. Okay, so it should look like this. Okay, and I'm actually going to extend this. Okay, so let me draw it this way. All right, like this. Okay, so what we're seeing here is that this side right here, okay, this red side should equal this other red side, okay, because it's a parallelogram, okay? So this should be 18, okay? All right, so at this point, I have a pair of parallel lines, okay, because I extended this bottom line. So this line is parallel to this line. And when I look at this, I see the weight vector as a transversal, okay, that is cutting this pair of parallel lines, okay? So if I extend this, okay, you can think of this as a transversal cutting this pair of parallel lines, okay? So that means that alternate interior angles are going to be equal, okay? So if I look on the interior of these parallel lines, I see angle alpha, okay? It has to be equal to its alternate interior angle, which is this, okay? This angle that I just measured off, that has to be, it's on the inside of the parallel lines and it's on the other side of the transversal. So this has to be alpha. Okay, but now if I'm looking inside this parallelogram, okay, I know that opposite angles have to be equal, okay, so that means this angle right here also has to be alpha, okay. All right, so now I am going to draw another box. Okay, so I'm going to move away from this green parallelogram. Okay, so this time I'm going to draw the box so that the weight vector is one of the diagonals of this box. Okay, so remember how I did this in the last problem. I'm going to draw straight back here so that this is a right angle. Okay, and I'm going to do the same thing over here. I'm drawing straight down so that this is a right angle. Okay. All right. So basically what I have here is that this new rectangle is made up of two triangles. Okay. So I've got this guy and then I've got this guy. Okay. Both have a right angle. Okay. We both have alpha labeled in each of the right triangles. Okay. Notice this side is equal to this side, which is 18. The length of this side right here is 18. Okay, because the way I drew this new rectangle, I drew straight down from here to here. Okay, so this side is 18. Okay, so that tells you that this side has to be 18. Okay, and if you remember from the very first triangle that we drew, I have since unshaded it. We know that if we had a right triangle, okay, there were three angles in the original triangle. It was theta, alpha, and then the right angle. So we know that theta plus alpha has to equal 90 degrees. So if you look at each of these triangles, the green one and the yellow one both have a 90-degree angle and they both have alpha. So that means that the remaining angle in each one has to be theta. Okay, remember, theta is what we're looking for. Okay, so at this point, okay, we can set up a right triangle ratio to solve for theta. Okay, you can use either the green triangle or the yellow one. Okay, if I look at the yellow triangle, and if I go across from theta, that's 18, that's the opposite side. And we know the hypotenuse, okay, that's the side across from the right angle, that is 74. So we can go ahead and say here that the sine of theta is equal to the opposite side 18 over the hypotenuse, which is 74. Okay, so this is something we just need to solve. Okay, and we'll have our angle theta. Okay, so I'm going to go to my calculator and type this in. Remember what we need to punch in. Theta is trapped by the sine, so to undo that, we need to take the sine inverse of both sides. Okay, so I'm just writing this out for your notes. So this is going to tell us that the sine inverse of the sine of theta is equal to the sine inverse of 18 over 74. On the left, the sine and the sine inverse cancel, giving you theta. So we just need to go to the calculator and punch in sine inverse of 18 over 74, and that will tell us the incline of the ramp. Okay, so let's do it. Okay, so make sure you're in degree mode. So this is going to be the sine inverse of 18 over 74, and this is the incline of the angle. Okay, so I'm going to write this all out for your notes. Okay, theta is 14.078, 0386. The directions say to round to the nearest tenth. Okay, so if we do that, that's one place after the decimal, so there is a 0 here. The 7 says we've got to bump this up. Okay, so we're going to see here that the measure of theta needs to be, I'll write it right here, theta is approximately 14.1 degrees. Okay, that is the incline that we have been looking for.